Usually, editing a video means, agonizing over timelines and pixels.
Oh yeah, frame by agonizing frame.
Right. You sit there splicing clips, masking out backgrounds, basically fighting the software every step of the way.
It's exhausting.
It really is. But looking at the massive stack of sources we have for today's deep dive, ranging from technical white papers to these macroeconomic analyses, the traditional video timeline is just dead.
Completely obsolete.
Yeah. We're looking at a landscape where you just talked your video and the scene changes right in front of you. Welcome to the AI Loop. Today is Tuesday, May 19th, 2026.
And we've got a lot to cover.
We really do. If you've got a pile of AI news and no time to process it, our mission is to cut through all that noise and deliver a direct summary of what's actually driving these shifts.
Was that all the hype?
Exactly. We're breaking down Google's native video generation, this incredibly aggressive corporate takeover by Anthropic, OpenAI hitting the hardware panic button, and the granular tricks developers are actually using to make AI agents reliable.
Because the overarching theme in the research this week, it's a fundamental shift in capability. I mean, we are no longer talking about models that simply predict the next word or generate a static image.
Right. It's way past that now.
Yeah. We are looking at agents that build, edit, and execute complex, multi-step realities across entire enterprise systems.
Okay, let's unpack this, starting with Google, because they just launched Gemini OmniFlash.
Which is massive.
It is. And looking at their product release notes, this is not a standard text-to-video generator where you type a prompt and wait like 5 minutes for a weird hallucinated clip.
No, it's natively multimodal.
Right. You can feed it any combination of image, audio, video, and text all at the exact same time. But the feature that really caught my eye is this conversational editing.
That's the game changer.
It's basically like having a hyper-competent Hollywood director right in your pocket. You hand them a napkin sketch, maybe an audio clip, and a script, and they instantly render a cohesive movie scene. You can take an existing video, tell the AI to change the main character's hat or make the lighting look like golden hour, and it just does it instantly. And it doesn't break the consistency of the background.
What's fascinating here is the mechanism that actually enables that consistency.
Yeah.
Because previous video AI generation was essentially just a highly advanced flip book.
Like drawing one frame at a time.
Exactly. The model knew what a ball looked like, so it drew a ball, then it drew a slightly shifted ball in the next frame, just trying to match patterns. It didn't actually understand how a ball bounces.
Okay.
But Gemini Omni operates entirely differently. It has an intuitive grasp of world physics. We're talking gravity, fluid dynamics, and object permanence.
Object permanence, like it knows something is behind a wall even if it can't see it?
Exactly. So when you ask it to change a video of, say, a glass sculpture melting into a mechanical lion, it is actually reasoning about the kinetic energy, the light refraction, and the structural integrity of those specific materials. It's physics-based reasoning, not just pixel prediction.
Okay, so previous AI was basically a flipbook artist drawing what it thought came next, but Omni is more like a video game physics engine.
That's a perfect way to put it.
It's calculating the math of the shattering glass before it ever renders the pixels, which explains the temporal consistency.
Yep.
And obviously, to stop people from using this to flood the internet with deepfakes, Google noted that all Omni outputs include a Synth-D digital watermark.
Right, which is crucial.
Yeah, because unlike normal metadata that anyone can just strip out of a file, this actually alters the pixel values at a level invisible to the human eye, but it's instantly readable by a detection algorithm.
And Google's also totally restructuring how these models deploy. Along with Omni, they launched Gemini 3.5 Flash and Pro, and they introduced this new framework called Anti-Gravity 2.0.
Anti-Gravity 2.0, I read the notes on that.
Yeah, it allows a single prompt to spawn multiple parallel subagents.
And they tied that into a new consumer product called Gemini Spark, right? It's like a personal agent that integrates with your email and local documents.
Yeah, but the killer feature there is that it works in the background.
Right, you give it a massive research task, you literally close your laptop lid, and it just keeps running.
Which represents a critical decoupling of human attention from AI execution.
Yeah.
Because until now, AI workflows required constant supervision.
You enter a prompt, you wait for the progress bar.
You review, you prompt again.
Exactly.
But by using Anti-Gravity 2.0 to orchestrate those subagents, Gemini Spark takes the objective, breaks it into parallel tasks, and executes them without tying up your screen time.
It changes the user from being an operator to being a manager.
Exactly.
And that transition leads perfectly into our next source stack, because while Google is pushing the physics of what AI can generate, Anthropic seems to be, well, systematically swallowing the corporate world whole.
It's incredible to watch.
Their enterprise blitz right now is staggering. Let's look at the numbers from the corporate press releases this week. KPMG announced a global alliance rolling out Claude to all 276,000 of their employees.
And they aren't just giving them a chat window.
No. They are wiring it directly into Digital Gateway, which is the proprietary software their tax and legal teams use daily. And PwC is going even further. They're deploying Claude to 300,000 workers and launching an entirely AI-native office of the CFO.
And the efficiency gains they're reporting are wild.
Yeah, PwC claims they're seeing up to 70% delivery time improvements in incredibly complex areas like insurance underwriting.
And it's not just the Fortune 500 either. They announced a $200 million partnership with the Gates Foundation.
Oh, wow, $200 million.
Yeah. They're using Claude to optimize agricultural data for smallholder farmers and tracking global health initiatives like polio and HPV. Plus, they launched Claude for small business.
Right, which wires directly into QuickBooks, HubSpot, and PayPal via their APIs.
Yeah.
But I have to pause here because my cynical alarm is definitely ringing.
Sure enough.
I mean, we've seen these massive corporate software announcements for decades, right? A firm buys 300,000 licenses, puts out a glowing press release, and a year later, the employees are still just passing around the exact same Excel spreadsheets they always have.
Sure, the adoption lag.
Exactly. So I have to ask critically, are these massive 300,000-seat enterprise rollouts actually changing day-to-day workflows? Or is this just high-level corporate PR masking a glorified chatbot deployment?
Well, skepticism is completely warranted based on historical enterprise cycles. However, the data extraction and workflow automation happening at places like PwC suggest a material shift, going from a 10-week cycle for insurance underwriting down to a 10-day cycle. That isn't achieved by an AI helping a human write a slightly faster email.
Right. That's an order of magnitude different.
Exactly. That requires autonomous agents running end-to-end data extraction across thousands of disorganized PDF claim forms, cross-referencing actuarial tables, running risk analysis, and generating the final report autonomously.
So they are fundamentally changing the workflow. They're shifting the frontier from models that just answer questions to agents that actually act.
Yes. And to do that, the agent needs to be able to talk to those messy legacy databases, which actually explains a very quiet but massive acquisition Anthropic made this week.
The Stainless acquisition.
Exactly. They bought a company called Stainless. And Stainless is a foundational player in building SDKs, software development kits, and API tooling.
So by acquiring them, Anthropic is clearly signaling that they are building the connective tissue required for Claude to interface directly with external software.
Right. Because if an agent is going to execute an underwriting decision or update a QuickBooks ledger, it needs robust, error-free API calls. Stainless provides that infrastructure natively.
That makes total sense. And it also explains why Andrej Karpathy just announced he is joining Anthropic to return to R&D.
Yeah, that was huge news.
Right. I mean, you don't bring in a heavyweight researcher like Karpathy just to tweak the tone of a chatbot.
No, absolutely not. You bring him in to build the architecture for autonomous multi-step execution. Because if PwC is suddenly running millions of automated insurance queries a day through Claude and 276,000 KPMG consultants are utilizing agents for legal document review, that requires a staggering amount of silicon.
Yeah, the enterprise scaling we're seeing creates an immediate physical bottleneck. Which brings us right to OpenAI's announcement this week. Sam Altman essentially hit the hardware panic button.
He really did.
He announced OpenAI guaranteed capacity. Basically, enterprise customers can now buy 1 to 3 year compute commitments. In his notes, Altman explicitly stated that the world is going to be capacity constrained for some time.
It's a major signal to the market.
It's like buying a VIP fast pass to a theme park right now, because you know the lines for the rides next year are going to be absolutely impossible to get through.
That's exactly what it is. Because for an enterprise building their core digital infrastructure on a foundation model, latency is fatal. If your automated customer service or your financial underwriting agents suddenly lag because the API is overloaded, your whole business halts. So OpenAI's move forces companies to lock in their infrastructure spend now or risk being throttled when the hardware crunch peaks. Meanwhile, OpenAI is aggressively trying to grab consumer market share to justify that massive compute spend. They pushed Codex into the ChatGPT mobile app, and they're offering 2 free months of Codex usage to pry developers away from competitors.
But throwing millions of dollars at guaranteed compute isn't the only way to solve the performance issue, right?
No, not at all.
The engineering notes we have from Cursor this week show developers getting around these compute limits by just getting fundamentally smarter with their training. Cursor launched Composer 2.5, which uses a new checkpoint from Moonshot called Kimi K2.5.
Yeah.
And the way they trained it to fix coding errors is kind of wild. It's called targeted reinforcement learning with textual feedback.
This is such a clever engineering solution. So the standard reinforcement learning paradigm has a massive flaw when applying to complex agent tasks. Usually, a model tries a long sequence of actions. Let's say it writes hundreds of lines of code, navigates 3 different files, makes multiple tool calls, and at the very end of that long trajectory, it gets a single reward score.
Right. So if you take a 50-question math test and the teacher just hands it back with a C at the top of the page, you have no idea which specific equations you messed up. You just know your overall performance was mediocre.
Exactly. Cursor solved the C on the test problem. They developed a method to insert a targeted text hint directly into the AI's context at the exact millisecond it makes a mistake during training.
Oh, wow.
So if the model makes a bad tool call on step 4 of a 50-step process, it gets a textual hint correcting that specific behavior. They use that hint to create a feature distribution, and then they update the student model's weights just for that specific turn.
So instead of grading the whole test at the end, the AI essentially has a tutor whispering in its ear to correct its grip the second it picks up the wrong pencil.
Exactly.
And it updates its understanding without unlearning all the successful steps it took before that mistake.
That is brilliant.
It is. And they combine that targeted learning with an underlying hardware optimization called dual mesh HSDP.
Okay, dual mesh HSDP, what does that actually mean?
So without getting totally lost in the weeds, HSDP stands for fully sharded data parallelism. When you train a massive model, you have to split the neural network's parameters across multiple GPUs because they literally won't fit on one chip.
Right.
But those GPUs constantly have to talk to each other to update the math, which creates a massive communication bottleneck. By using a dual mesh topology, Cursor optimizes how those parameter updates sync across the network, vastly accelerating the training efficiency without needing to buy twice as many chips.
So they're just routing the math way more efficiently.
And it pays off in their new cloud agent development environments because they are letting these newly trained agents loose across massive multi-repo code bases with full access to testing and build tools.
But reading the deeper technical documentation from Anthropic this week, getting an AI to actually navigate a complex environment, whether it's a massive code base or just a basic desktop screen, it still requires an incredible amount of manual scaffolding.
Oh, absolutely. The defining challenge of the current frontier really is reliable computer use. Anthropic released this comprehensive guide to best practices for deploying agents in production, and it reveals a massive gap between a model's theoretical intelligence and its actual mechanical execution.
The gap is huge.
The biggest tip in their documentation completely blew my mind. So if you are building an AI agent that looks at a screen to click buttons, you absolutely must pre-downscale your screenshots before sending them to the API. Because if you take a pristine, massive 4K screenshot of your desktop and send it, the API hits an internal limit. For the Claude 4.6 model family, that limit is 1.15 megapixels. So the API silently downscales your beautiful 4K image before the underlying model ever even sees it.
And that silent downscaling just catastrophically degrades the agent's click accuracy.
Right. So if you send the AI a massive 4K screenshot without downscaling it first, it's like handing someone a giant, highly detailed map, but forcing them to look at it through a blurry, smudged magnifying glass.
Exactly.
They literally cannot find the tiny side street they need. And worse, when the AI tries to click a checkbox, its coordinate math is completely broken because the downscaled grid it's looking at doesn't match the pixel dimensions of your actual screen. It just misses the button entirely.
It's completely blind to the actual coordinates.
Yes. Yeah. So Anthropic's documentation says the safe, practical default is to pre-downscale your environment to 1280 by 720 pixels.
Which perfectly illustrates the crucial difference between mechanical precision and logical reasoning. I mean, clicking a 16-pixel checkbox is a perceptual mechanical task. It does not require deep cognitive processing.
Right.
And that is why Anthropic strongly advises developers to set the thinking effort to medium for user interface tasks, rather than max. Using max effort on a visual UI task just causes the model to waste expensive tokens overthinking a purely mechanical problem.
So you save the heavy logical reasoning for the orchestrator agent, and you let the smaller, faster models like Claude Haiku handle the perceptual clicking on that 1280 by 720 screen.
Exactly.
And there was another great structural trick in the prompt array they mentioned. Developers should always put their text instructions before the image. You tell the AI, find the submit button, and then you show it the screenshot.
Ordering the prompt that way primes the model's attention mechanism before it processes all that heavy visual data. And we see similar structural scaffolding required when shifting from visual screens to massive text environments, like, millions of lines of enterprise code.
Right, because you can't just dump all that in.
No, you can't just use standard retrieval augmented generation where you dump the whole code base into a database and run similarity searches. Because in a massive enterprise system, the code changes too fast, and simple text searches lack the necessary context.
So how does Claude Code actually navigate a multi-repo code base if it isn't just searching for text strings?
Well, they utilize hierarchical keylod.md files. Think of it like a dynamically loading map. There's a root file outlining the architecture, and as the agent navigates into subdirectories, it reads local files explaining the specific conventions of that exact folder.
But that's smart.
Yeah. But more importantly, they integrate LSP, or Language Server Protocol.
Right, I've seen that term everywhere lately. How does an LSP actually change the way the AI reads code?
Okay, so if you just use text search to find a function called, say, calculate tax, you might get 1,000 results across the code base, and most of them are irrelevant.
Yeah, that happens all the time.
LSP is the underlying technology that powers modern IDEs for human developers. It creates a structural understanding of the code. So instead of using a done Ctrl LF to search for a word, LSP allows the AI to select a function call and jump directly to its exact definition in another file, regardless of where it lives.
Oh, wow.
It's basically the difference between looking for a word by flipping through every single page of a book versus having a hyperlinked index that takes you exactly to the core concept.
So the intelligence of the model is clearly there, but the success rate entirely depends on how developers build the scaffolding, the downscaled images, the LSP links, the targeted textual hints, just so the AI doesn't get overwhelmed.
Exactly. It's all about the mechanics now.
Which perfectly bridges into the macroeconomic and geopolitical analyses we have in our stack for the take of the week. Ethan Mollick wrote a piece highlighting a massive shift he calls insourcing.
Yeah, and this is a profound economic pivot. For the last 30 years, the dominant corporate strategy was outsourcing, right? If a firm needed custom software, marketing assets, or legal discovery, they hired an external agency or bought a SaaS subscription.
Of course.
Mollick argues that agentic AI enables the exact opposite behavior.
Think about the last time you had to hire a freelance graphic designer or an external coding firm to build an internal tool. What Mollick is pointing out is that a single manager, armed with multi-agent systems like Gemini Spark or Cursor's cloud agents, effectively becomes the entire agency.
Exactly.
Mid-sized companies are using these highly scaffolded agents to build their own bespoke in-house software solutions rather than paying external retainers.
And that insourcing trend brings us right back to the physical infrastructure bottleneck we discussed with OpenAI. Because if every single company brings their digital processing in-house via these intensive agent workflows, the demand for localized data centers just skyrockets.
It does. And Gary Marcus highlighted recent polling data this week that shows a massive roadblock for that infrastructure. According to the numbers, 71% of Americans now oppose local AI data centers being built in their communities.
That's a huge number.
It is. To put that in perspective, the public is currently more comfortable living next to a nuclear power plant than an AI data center.
From an infrastructure standpoint, this introduces a hard physical ceiling to AI scaling in the United States. I mean, the intelligence of the models is completely irrelevant if local zoning boards and public sentiment block the construction of the power and compute clusters required to actually run them.
Which makes the final piece of our stack from Jan LeCun feel like a ticking clock. LeCun issued a stark geopolitical warning regarding open source models and national security. He argues that if the United States overregulates AI capabilities, locks down its tech ecosystem, and restricts open source development due to security fears, the strategy will completely backfire on a global scale.
And this analysis highlights a severe tension for policymakers. Because obviously, restricting frontier models aims to protect national security. However, if the U.S. ecosystem becomes an expensive, highly regulated walled garden, developers in emerging markets won't just stop building.
Right.
Across Africa, Latin America, and Southeast Asia, institutions will naturally adopt the highly capable, self-hostable open models provided by China. LeCun's projection is that by 2030, Chinese open models could become the default operating system for 6 billion people in the global south simply by being accessible when U.S. models are restricted.
It's a fascinating macro shift to watch. Well, we have covered a massive amount of ground today. Let's do a quick recap of the core shifts.
Let's do it.
Google's Gemini Omni is abandoning flipbook pixel prediction for physics-based world reasoning, which makes video editable by conversation. Anthropic is wiring Claude directly into the legacy infrastructure of 300,000-person enterprises, and they're buying the API tooling to let those agents take autonomous action. OpenAI is locking down long-term compute capacity as the physical hardware crunch collides with local zoning board opposition. And down in the engineering trenches, developers are relying on precise mechanical scaffolding, like downscaling UI screenshots to 720p and using LSP indexing to make sure these models actually click the right buttons.
The through line connecting all these sources is really the transition from generation to reliable execution. The models possess the underlying knowledge. The entire industry's focus is now on the physical compute and software mechanics required to apply that knowledge flawlessly in the real world.
Which leaves us with a final thought to chew on. We started this deep dive looking at a hyper-competent AI that can calculate the physics of a shattering glass just from your voice. We've seen how developers are giving these agents the tools to navigate massive code bases, execute financial underwriting, and completely bypass human bottlenecks.
It's all moving so fast.
It really is. So if the friction of both creation and corporate management is dropping to near zero, and these systems can insource the work of entire agencies, what happens to the human role when a multi-agent system decides to design, fund, and launch the next generation of software startups entirely on its own?
The automation of execution really forces us to reconsider where human value is truly generated.
Something to mull over until next time. Thank you for tuning into this deep dive. Keep exploring, stay curious, and join us again next week for the next update.